We're going to start with introduction to API today. So mostly for today, we have mostly theoretical stuff. I'll be giving a basic intro on APIs, like the basics of REST API, an overview to Node.js and its features, architectures that you can use with Node.js, and some interview tips as well. So when I say the keyword interview, do jot it down somewhere on paper because it won't be available on the slide. So some of the interviews are usually used in technical interviews or technical tests. All right. So let's move forward. So REST API. So REST is a representational state transfer. It is like a way for you to communicate with other programs, a set of documentations that specifically states what each of the endpoints does, let's say returning a set of data, and what kind of data that you should expect. So the standard here is that it is very uniform. You can use it throughout any kind of language or any kind of framework, and you will be expecting the same kind of results. So here's the basics of REST API. You would have your clients on the left side, and then on the middle, you would have your REST API, your backend server, and then you would have your database. So the flow would be from the client side to the REST API. They will request based on the endpoints and the verb or that they use. So right here we have get, we have post and page, and the endpoints that they use, all users, new users, and update user. So they request data from REST API. So from your server to the database, you would query your database and then return to the client the respective data that you're supposed to return. So these are the typical HTTP verbs that you usually will be using when you're developing your program. So you have get, which is basically read from the database, put, update, or replace row in database. We have patch as well, about the same with put. We have post to create a new record in the database, and then we have delete from the database. So let's break it down. Oops. So the breakdown of a URL, to make sure that there is a standard across the platform, we have the verb that I've mentioned just now, and then we have the base URL, we have the endpoint, and then we have the query parameters. So in a way, the way that you query to an API, or when you're creating an API, it is more understandable by other people. It's documented properly with the actions that you want to do. So for example, I'm getting all the characters from Marvel with this parameter. So let's say I use name starts with C, then Marvel would then return me a list of characters that start with C. So it may contain Captain America, Captain Marvel, and so on. So that's when you are requesting a resource from server. So what would the server return you instead? So this is the response. So there's three main parts of a response. We have the status here, the header, and then the body of the response. So the status would be the 3-digit number that tells you what's the outcome of the API request. So for example, we have 200 for OK. We have 404 for resource that is unavailable or missing. And then we have status 500 for any internal server that blocks those requests. And then we have the header inside the response. So it is an additional information, some sort of metadata about the response. So right now, the header would specify that we are receiving a JSON response with the timestamp as well as the content length. And then we have the body that you can access the data inside. It can be in lots of format, but usually it will be in JSON or XML. All right. Okay. And this is what it would show on the front end. So we have a list of characters, a list of character spotlights, and depending on how you structure your website or mobile apps, you can use the data from the API with the images and the data that is in the response. So I would show it like an example, a little bit of an example. Oh, right. So right now I'm on my Postman. So Postman is a graphical user interface that you can use to test API. So right now I have the Marvel API. Now what I can do is I want to carry characters that starts with SPI. So hopefully I get Spider-Man inside. We have Spider-Dog. We have Spider-Girl. So let's say I want to focus more on Spider. Let's send that request. Yeah, we have Spider-Dog in the results, Spider-Girl, another Spider-Girl, Spider-Gwen. So quite a lot of spiders there. And then it depends on the endpoints that you get. So since from Marvel, I don't have endpoints to modify their data, all I get is the URL for getting the resource. For example, I have comics as well here. Let's try to send something. All right, so we have a list of comics. Sometimes the API would also give you metadata such as offset, limit, that would help you to get the pagination right on each of your page. You will start from 0, and then the next one you would start from 20, and so on. And then we have the length of each data that we receive. And then we have the actual results. So if you want to try out other free APIs, there's quite a lot that you can do with REST API. So let's go to Rapid API. So let's say you're building a calorie calculator for foods. So you would have something like, where is it? Free public APIs. So you can go there and there's a list of free APIs. So we have real estate, we have Google Translate, we have finance, sports, cities database. You can access Instagram, video games database. I've actually used this one for an interview. And there's quite a lot of other data. Like back then when the pandemic hits, COVID-19 APIs were quite popular back then. We have other categories as well. Let's say we want to do like food. So we have cocktail DB, recipe, nutrition. So learning how to access an API and learning how to build a very good API, it takes a certain amount of skill and test for each of the APIs that you want to use. So let's try to go to nutrition. So again, the database is properly documented. We have the get, the request URL, the parameters, and what we can expect from the API. So we have example response here. So we have Coke, cherry Coke, and the ingredients that would contain in that recipe. And then we have the nutrition value. So quite a lot of things that you can do with REST API. So if you ever want to start building something that uses an API, do look out for free public access API. All right, moving on. So when you're building REST APIs, there are about 6 principles of REST API. 5 compulsory and 1 optional. So let's go through that. So we have the client-server architecture. So basically what you would want to have is you would have your clients, your mobiles, your mobile apps, your website, IoT device, your computers. It would access the server, and that's it. Whatever is in between, for example, your database, authentication services, that should be separated from your that flow. So it should be client and then server, and then that's it. And the client won't have to worry about how the server stores or retrieves the data. And then it should also be uniform. So whether the client is a software application, mobile apps, it should be able to access the REST API in the same way. So as a developer, you're supposed to make this kind of thing a standard, such that if there are multiple teams in your company, you have mobile apps team, you have the web team, so they should be able to access those API the same way across the board. And it has to be stateless. So the server does not have to care what is happening in your browser, doesn't have to care what you're doing, what you're clicking. What it matters is that when the client sends a request, the proper response is given. And it is totally up to the client on how they store those data. So for something like if you use React.js, Vue.js, or even Flutter, you would have your own state management to manage that data inside your app. And REST API, it should be cacheable. So a cache would usually be stored on a RAM server, a very RAM heavy server. So tools like Redis can be used. So for example, when you hit a request, when a client hit a request, the first request would be cached in memory. Then the data would return to that user. But for example, if you were to have 1 million users hitting the same request over and over again, it would make more sense to pass the data that is cached from the memory, because memory, the performance of a memory of the RAM compared to a database is about 1,000 times faster. So your response would be faster and your database resource wouldn't be used as much. And then we have layered system. So the idea is that you have your clients, you have your server, and then whatever behind that, your database, your services, your cache, that should be kind of hidden from your clients. Your clients should not know anything about those implementations. And then back then, we used to use a lot of Flash on the browser. So code on demand means that some functions can be downloaded to maybe Java applets or JavaScript scripts to access additional functionality, meaning that you download the scripts and then you run it in your system. So back then we have Flash, like Flash games, you would have a loading screen while it loads all the codes from the server, and then you would play the game. So that's 6 principles of REST. So now to keep your API secure, we do have practices that we need to do. So it keeps bad actors away, it keeps bots away, it keeps those spammers away. So it either blocks those bad actors or it will either slow them down, depending on your use case. So in my experience, when a bad actor tries to spam an endpoint of mine, and that endpoint would incur large costs if being called multiple times, like let's say 100 or 1,000 requests per minute, that would be very expensive. So one way was I would first slow them down. So if they're trying to access it, let's say giving me 10 requests per minute, I would try to rate limit them even further. I would limit it to 5 requests per minute and so on. But if they keep repeating to do that, I will ban their IP. So you can do something like that as well. There are other methods to keep your API safe, like the example that I showed you just now with Marvel API. I'm supposed to give a token to them to validate my existence, to validate my authorization so that I can use their API. So there are multiple mechanisms that you can use. You can use tokens, you can use API keys, and you can use OAuth. OAuth is something like you log in to the REST API, and then the REST API would return you a token. And with that token, you can either refresh your token, and then you can also call endpoints. So in terms of, let's say, a real world product, and you are using the Twitter mobile client, you would have to first log in to Twitter before you can access your own data, before you can access your Twitter feed, like your personal Twitter feeds and your DMs and stuff like that. So you have to be authenticated and authorized to access those data. And then you have to choose the right security measure. So something like what I've said just now, IP banning, IP rate limiting, that would be a very good measure to take when you're trying to secure your API. And then some considerations for securing sensitive data. Maybe you want to encrypt some data, because when you're passing data from the server, passing the response from the server, your client may not need to know what's going on in between, and they can decrypt data and show it to their mobile. There are some fancy use cases for this one. Let's say if you want to upload medical data and it would only be for the user, so the user can encrypt that, bring that to the server. The server next time will pass back me the encrypted version, and then I can decrypt that for my eyes only. So if that was your strategy, even the admin of that system can't even look at your data, meaning they can look at your data, but the data won't even make sense to them. So your privacy is ensured.